Hey guys, welcome back. Today we're going to go over how to multiply and divide rational functions. Now, the steps for that, we're going to factor the numerators and denominators, which is just like when we added and subtracted. And if it's division, we have to do the inverse and multiply. Then once we're at the multiplication step, we just multiply across, and then you can cancel any common factors to simplify. So, looking at this first question, we want to factor the numerators and denominators. Now, there's a lot here that we can factor. We can factor this first one. We can factor the bottom. And we can factor this one. So let's start with this first one. This is the diamond method. We have a trinomial. There's no number in front of x squared, and there's no x on the 9. So we have a times c on top, b on bottom, with our ax on top. Now, two numbers that multiply to give us a 9 and add to give us a negative 10. So I know 1 and 9 are going to give me 10, but I just need to make sure they're both negative to multiply back to get a positive 9. So that means for this parentheses, we're going to have x minus 1, x minus 9. Now, for our second one, I'm going to say that's difference of squares because I could take the square root of x squared, and that will give me x, and I could take the square root of 1, and that gives me 1. So my two parentheses here are x plus 1, x minus 1. And then on the very last one, I'm also going to say that's a diamond method. Remember my considerations. There's no number in front of x squared that could potentially be divided out by all of them, and there's no x on the 36. So we have negative 36 and a minus 5. And then we have a times x on top. Now I know 9 and 4 multiply to get 36, and the difference between 9 and 4 is 5. So if I just make the 9 negative and the 4 positive, that's going to give me a negative 5. So we got x minus 9 and x plus 4. Okay? And now we're just going to rewrite all of these fractions, because they're fractions just with x's in them, with what we just found. So on that first fraction there, we have this green one over the purple one. And on this second fraction here, we have our x plus 4. I'll go ahead and put that in parentheses. And we have our red one here. Okay, so now that we're at a multiplication, we've already factored everything, we're going to multiply across. And that just basically means we're going to write everything next to each other. So I have x minus 1, x minus 9, x plus 4 over x plus 1, x minus 1, x minus 9, x plus 4. Now we're going to look for what cancels. I have an x minus 1 on top and bottom, so I'm going to cancel that. I got an x minus 9 on top and bottom. I'm going to cancel that. I got an x plus 4 on top and I'm going to cancel that. And now all I have left is 1 on top and an x plus 1 on bottom. So this is 1 over x plus 1. Okay? Now, I feel like once you factor everything, canceling everything out is pretty straightforward to simplify. So let's look at a division problem. So we have this x squared minus 4 over x cubed divided by x to the 5th minus 2x over 2x to the 4th over x plus 4. So let's look and see what we can factor. So I'm going to say this one can factor using difference of squares. X cubed is just one term. Anytime you have one term, you cannot factor it. On the top here, I see some x's on both terms, so I'm going to assume that we can factor out a GCF. And then on the bottom, we just have x plus 4, which is already factored. So let's go through and factor number 1. I can take the square root of x squared, and that gives me x. I could take the square root of 4, that gives me 2. So I have x plus 2, x minus 2. Now on this second fraction here, I said we could do a GCF. So I'm going to rewrite each term with all the way broken down. So I have 5 x's, and then I have a negative 2 and 4 x's. So anything I can take out that's a pair between the two, like this x, 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 I could divide. So, oh, I'm sorry, I have one extra x here. So I'm going to take x to the 4th out, and whatever I have left is what goes inside my parentheses. So I have 1x and a minus 2. Okay, so now we factored everything. This is a division problem, so we need to take the inverse and multiply. So that means on the fraction on the right, we're going to put the bottom on the top, and then we're going to change our division sign to a multiplication sign. So let's go ahead and rewrite everything. We had an x plus 2, x minus 2, and then on the bottom, we had an x cubed. We now have a multiplication problem. We have an x plus 4 on top. And on the bottom, we have this x to the 4th times x minus 2. Okay, and then we're just going to multiply across. So we have x plus 2 x minus 2, x plus 4 over x cubed times x to the 4th, that gives us 7 of them, x to the 7th, x minus 2. Okay, and we're just going to look for what cancels. So I have x minus 2 on bottom, x minus 2 on top. And when we're canceling, we want to make sure we're canceling the whole parentheses. So I'm not going to take away any x's inside the parentheses with my x over 7. So that just is going to leave me with x plus 2, x plus 4 over x to the 7th. And that's it there. So I think I have one question for you guys to try. Yeah, so go ahead, pause the video, try this one, see if you get it right. Let me zoom in here. Okay, and here is what I got when I multiplied everything, when I factored everything out. Now let's just see what cancels here. So I have a squared plus 4 on top. I have a plus 4, a minus 4 on the bottom, and then we inverse and we multiply. So I'm going to put this a plus 5, a minus 4 on top, and my a plus 3, a plus 5 on the bottom. Now I see I have this a minus 4, those will cancel. I have this a plus 5, that will cancel. And everything that I have left is a squared plus 4 over a plus 4, a plus 3. Now remember, if the parentheses don't match exactly, we can't cancel it. So we can't cancel that a squared plus 4 over a plus 4. Okay? Good job, guys.